Hi guys, we're going to continue our quadratic function unit. We're going to take a small break from the graphing and we're going to focus our energy on finding the equations of quadratic functions given some information. So the fun problem reads, find the equation of a quadratic function whose graph satisfies the given conditions. Write the equation in standard form, and standard form for a quadratic function is such. Okay. So what do I know? We know that the vertex is given by -2, -12, and then that the x-intercept is at -4. As an ordered pair, it will be -4, 0. I understand that we are to ultimately write the equation in standard form, but this is the thing. They give us the vertex. This is HK. There is no reference to vertex here. Okay, so because they give us the vertex, we're gonna go ahead and write the vertex form of a quadratic function. So a quadratic function is said to be in vertex form if it looks like this: a times the square of x minus h plus k. Oh yeah, that's beautiful. Okay, so we're gonna plug in what we can. We're gonna plug in the coordinates of the vertex and then the coordinates of this ordered pair, which is the x-intercept. Okay, so we have f of x, which is just another name for y. We have y equals 0. That should equal a. There is no reference to a here, so it's gonna stay as a, times the square of x. X is -4 minus h. H is -2. H is the x coordinate of the vertex squared, plus k, which is the y coordinate of the vertex. Fantastic. Okay, so let's take our time and do this. Where am I? Sorry. So that gives us 0 equals a times the square of -4 minus -2. Sorry, I need to do this. It's the same as -4 plus 2, or -2. And this is in my way, so we're going to just put -12. I mean, you're pretty good at arithmetic, so you can probably skip a lot of steps. But when I skip the steps, well, when I don't write them, I tend to make silly mistakes, so I write everything. So we have 0 equals 8. Square of -2 is 4. Let's go ahead, add 12 to both sides to isolate the variable term, and that will give us 12 equals, my mistake, 8 times 4, or 4a. And then to isolate the a, to get rid of the times 4, let's go ahead, divide both sides by 4, and that will give us a equals 3. Okay, so let's come back to our problem. Okay, so where should we continue? Well, we don't have reference to b or c, so let's come back to the vertex form of a quadratic function. So that gives us f of x is equal to a times the square of x minus h plus k. What are we gonna plug in? We're actually gonna plug in, where am I? We're gonna plug in the coordinates for the vertex. What's the vertex? -2, -12, and then we're gonna plug in the value of a. Fantastic. Let's punch it in and then take it from there. So we have f of x equals a, thanks to our hard work, gives us 3, times the square of x minus h, so it'll be x minus h. So the vertex is of the form hk, so h will be -2 squared plus k, which is -12, and that's pretty much the answer. The reason why it's not accepted for full credit is because we have to put it in standard form. Okay, so we have f of x equals 3 times the square of x plus 2 minus 12. Let's go ahead, expand the x plus 2. Okay, so this will give us, where am I? F of x equals 3 times, and expand it however you want. If you feel comfortable taking the multiplication shortcut, squaring the binomial, go for it. But I forgot how that works, so I'm just gonna old school it. I'm gonna FOIL it out. Let's write it without the exponent of 2. So that will give us x plus 2 times x plus 2 minus 12. Take your time, FOIL it out. Let me go ahead, put these brackets right here. So product of the first terms will give us x squared, product of the outer terms 2x, product of the inner terms another 2x, and product of the last terms 4. Okay, take your time, you got this. There's no time for arithmetic mistakes. When we combine the like terms, the sum of the middle terms gives us 4x. And we're this close, I could taste it. Let's go ahead, distribute that 3, clear those grouping symbols, and that will give us 3x squared plus 12x plus 12 minus 12. And then let's go ahead, combine all the like terms. We only have one squared term, we only have one x term, and the sum of the constant terms surprisingly gives us 0. Okay, so we have f of x equals that. If you wanted to check your answer, well, you can check it in more than one way, but if you wanted a visual confirmation, just punch it into your calculator, verify that the vertex is indeed -2, -12, and that the x-intercept is -4. So did we really answer the question? So it says find the equation of this bad boy, and then write it in standard form. Okay, that is in standard form, so we expanded the factors, so we're good. Okay guys, thank you.